Hi everyone, hope you are doing good today. Today I am going to start a new chapter, chapter 5, which is based on probability and random variables. Under this chapter 5, first section is probability basics. So, what are these probability basics? In inferential statistics, I hope you may remember that what is this inferential statistics, which mean we use our sample to draw a conclusion about population. But remember that we can never be get a certain conclusion, which mean we cannot say our conclusion about population is 100% accurate. Okay, there is some uncertainty in inferential statistics. This uncertainty we call probability. This uncertain we call probability theory. Okay, the probability theory would be useful to evaluate and control likelihood that a statistical inferential is correct. So, this uncertainty we use to control likelihood, so that we can measure or we can evaluate that our statistical inference is correct or not. Probability is likely outcomes, it's for equally likely outcomes, simply frequency divided by total number of outcomes. So, as you can see here, we have capital N possible outcomes, all are equally likely. An event that occur in simple f number of ways. So, the probability of that particular event is simple f, which means event that occurs, event that event that occurs in number of ways, divided by total number of possible outcomes. Total number of possible outcomes. Okay, let's check this picture. In this picture, you can see there are two dice. First one is the red color, the other one is the black color. So, there are two dice. If you flip, let's say die number 1, we call this okay, I'll write it red die, red color, red color, I call that first one, black color is second one. Okay, so when I roll the first die, which means red color die, I can get these possible outcomes. See, I can get number 1, I can get 2, 3, 4, 5, 6, whatever, but at once only one number. Okay, so when I flip black color die, I can get these values 1, 2, 3, see 2, 3, 4, 5, 6. Okay. For red color die, we have values from 1 to 6. For black color die, we have again values from 1 to 6. Okay. Okay. Possible outcomes. So, these are the possible outcomes. If we roll the red color die, I can get 1. Okay, for an example, first I roll the die, a red color die, I can get 1. Next, I roll the black color die, I can get 1. Okay, it's a possible outcome. What happen if I get so this is the outcome. What happen if I if I roll the first dice, which mean red color die, and I get 4. Okay, so red get 4 and black color die gives me 1. So red appears 4, black appears 1. So where is 4 1? Red 4, black 1. So red 4 is in this line, red 4 in this line, black 1 is this one. So that's the outcome. Likewise, you can see all possible outcomes in this picture. Altogether there is 36 outcomes. So altogether we have 36 outcomes. This side 6, row wise 6, column wise 6. So 6 by 6, it is 36. So altogether, if I roll 2 dice, I can get 36 number of possibilities. Okay. Okay. What are the basic properties of these probabilities? There are specifically there are 3 properties. First property is probability of an event. Probability always measure of a event. Probability of what? You have to mention probability of what? Event. This should be an event. You have to name this event, but later we will do those things. This is how this probability works. Probability of what? Probability of an event. Probability of an event is always between 1 and 0 inclusive. Always between 1 and 0, including 1 and 0. So probability values definitely within 0 and 1 range. There is no probability values like negative 1.1 or 1.523. There is no probability values like that. Okay, definitely probability values are in between 0 and 1, including 0 and 1. Okay. Property 2, probability of an event that cannot occur is 0, which mean, okay, I will write it here, probability of what? I will consider this event. Okay, event, this is my event, is equals to 0, which mean this event never happens. This event never happens. This event never happens. Okay. If probability of this event is equals to 1, then what happen? This event definitely happen, which means this event must occur. Okay, that's what this property 2 and property 3. If the probability is 0 of that particular event, that event impossible to happen. Or on the other hand, the probability of that event is 1, then that event must occur. Okay, which means it is a definitely event. Okay, let's check this example. There are 6 students in the class. There are names and Joshua, Ben, Mason, Emma and Olivia. So I can consider these capital letters in the brackets. We are selecting 2 persons randomly among these 6. Okay, So we need to check what is the total possible outcomes in this situation. We have 6 students, we have to select 2 by 2. I mean, at a time we can select 2. So we need to write all the possible pairs, simply pairs, because we have to select 2. So you can start from capital A, which means and. So with and we can write, okay, and denoted by capital A. With and I can select Joshua, J, comma. With and I can select Ben, so A, B, comma. With and I can select Mason, A, M. With A I can consider Emma, E, A, E. With an I can consider Olivia, O, A, O. Is that all? No. Now I can consider Joshua. With Joshua, which means J, I can consider B. Okay. With J, I can consider M. With J, I can consider E, and with J, I can consider O. Can you see the pattern? So first try to catch one guy and try to make a pairs with him, with all of them. Okay. So okay, Joshua has gone. Now you can select capital B, which means Ben. So with B I can consider capital M. With B I can consider what is this, E, capital E. With B I can consider O. Okay. Okay. Now how many students I have considered? First 3. Okay. What about M? If I select M, with M I can consider capital E, or with M I can consider capital O. Okay. Mason is gone. Now Emma. With E I have only one choice, O. Okay. So don't worry about the repetitions or order. See, for an example, AJ, Anna and Joshua, don't consider JA, Joshua, Anna. It's same, okay, because we are talking about person, we are talking about students, okay. So for students, Anna, Joshua, or Joshua, Anna, it's same, okay. So try to make distinct pairs. There is no repetition in this selection, okay. So this is this is the way how we mention all possible outcomes, okay. If you want, you can use this curly bracket. So within this curly bracket you can mention all the possible outcomes. So let's count how many outcomes: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So altogether there are 15 outcomes, or all possible observations, okay. Okay, let's go to the next one. Find the probability that we obtain Emma and Olivia as our sample. So within our sample, or within our all possible outcomes, Emma and Olivia should be there. So definitely Emma and Olivia should appear. Emma and Olivia. So this means E and O. Okay. So you can check this pair, Emma and Olivia. It is in the last part. It is in the last pair. So we have only one. Emma and Olivia only in once, right? So how do we calculate the probability? Frequency of our event. What is my event? Okay, I'll write down it here. My event is Emma and Olivia, I will write it shorthand note EO as our sample. Okay, this is my event. So probability of my event, okay, event, this is my event, is equals to, what is the frequency of my event? Just 1, divide by all possible outcomes. How many? 15. Okay, you can keep it like this, or you can just using calculator you can get the decimal value. Clear? Okay, find the probability that Mason is included in our sample. Now we have only one guy. Okay, the other one can be anyone, doesn't matter. It can be Anne, Joshua, Ben, Emma, Olivia, doesn't matter. But Mason should be there. So you can first take a look at this all outcomes and check where we can find capital M. So I can see we can get M here, right? You can check it with me. Capital M here, capital M here, M again capital M here, M, capital M here, right? So how many capital M's? 1, 2, 3, 4, 5. Okay, so my event is Mason. I'll write down it under quotation marks. Mason is included in our sample. Okay, this is my event. So probability of this event, I'll put the bracket here. You have to write down this event. Mason is included in our sample. Okay, is equal to, so what is the frequency? 1, 2, 3, 4, 5. So frequency of this event is just 5. What is the total number of outcomes? 15. So you can simplify this 1 over 1/5, right? 1 over 5 1/5, which means 0.2. Okay, so this is the probability. See this value, the 0.2 in between 0 and 1. Clear? Okay, let's check this example 2. Consider an experiment that tossing a coin 3 times. Okay, this coin I am going to flip 3 times. Okay, 3 times. So what are the possible outcomes? Head, oh sorry, this is going to be head. So 3 coins, flip 3 coins, flip, right? Experiment that tossing a coin 3 times. Okay, tossing a coin 3 times or tossing a 3 coins 1 time, same situation. Okay, but here they have mentioned okay, tossing a coin 3 times. Okay, this is my coin, that's why I mentioned head in all picture 3 times. So what are the possible outcomes? If I flip a coin once, okay, 1 time or first time, what are the possible outcomes? Head or tail, right? What happens second time? Second time, same outcomes, right? Head or tail, but there is a case, there is a situation you need to consider. In second time, you have to consider previous results. You cannot simply say okay, head and tail. First time you have head or tail, okay, but second time when you flip the coin, you have a past memory. Okay, so previous result you have to consider when you write down the coin tossing 2 times. So let's say first time I got head, in second time I got head as well, right. First time I got head, okay, but second time I got tail. First time I got tail, but second time I got head. First time I got tail and second time I got tail. Clear? Okay. Third time I will write here. Third time what will happen? You cannot simply consider head and tail. You have to merge your results head and tail with your past memory. So what is the past memory? Second time you have these kind of results. So you don't need second time, you can start from the very beginning, from the first time. So first time I have head, second time I have head, third time I have head, right. We have only 3 flips. So first time head, second time head, then what happened? Third time tail. First time head, then what? Second time tail, and again third time head. Okay, first time head, second time tail, third time tail as well. Clear? Okay, next, first time I got tails, first time tail, second time head, third time tail, head as well. First time tail, second time head, third time tail. Okay, so I need more space. So first time tail, second time what gonna be the, this should be tail, second time tail, third time head. Okay, what's the other one? First time tail, second time tail, third time tail. Okay, I think these are the possible, all possible outcomes. Yes. Can you imagine any other observation rather than these 8 cases? There are 8 outcomes. Can you imagine something outside from this 8? Okay, okay. For flip a coin 3 times, this is my possible, all possible outcomes. Okay, all outcomes have equally likely chance. Definitely, all of them have equal likely chance. Let the event be the sample obtained having one head. Okay, this is now my event. This is my event. What is that? Sample obtained having one head. So probability of having one head, probability of my event having one head, you can count having one head. Having one head mean you can have one head, you can have 2 heads, or you can have 3 heads. So you have to be careful with these words. Obtained having one head, which mean you can have 1 head, 2 head, 3 head. Okay, if they have mentioned obtained having one head only, then definitely you have to stick with 1 heads. Okay, now we can calculate at least 1 head, right. 1, 2, 3, 4, 5, 6, 7. There are 7 outcomes for this event, 1 head. Altogether I have 8. Okay, so probability of having 1 head is 7/8. Clear? Okay. Let's consider this one. Following table, the following table shows number of cardiovascular diseases by age group during 1 year. Okay. What about this one? Okay, I'll do this example. The following table shows number of cardiovascular disease by age group. Okay, they have mentioned their age groups and frequencies. So, this is the total number of outcomes. This is the total outcomes. Clear? Suppose that you select a woman randomly, then find the probability that selected woman is in her age 51. So, age 51 in this case, right? Age 51 includes this age group. So, what is the frequency? This much. So, probability is equal to, this is the frequency, 20,983 divided by total outcome is 208867. So, you can use your calculators and get the value, decimal value. Okay. Next one, find the probability that selected woman aged between 50 and 79. So, 50 and 79, okay, which mean this group, right. So, you have to calculate what is the frequency within this group. So, first you have to add 20,983 plus 36884 plus 65017, get the value. Okay. Can we get the value this one? Okay, I will write down this value. It should be 1041. Okay, value is this one. Okay. Now, probability of selected woman age between 50 and 79 inclusive. Okay. So, the probability value is probability of what? Probability of what they have mentioned, selected woman age between 59 and 79 inclusive is, this is your frequency divide by total number of outcomes 20, 88, 67. Okay. So, calculate it, get the decimal value. Find the probability that 70 years or older, 70 years or older, 70 or older, 70 or older mean including 70, you have to what? You have to consider these two. Okay. Get the summation of these two values and divide by total number of outcomes. Okay. I am not going to write it down. Less than, let's see the next one, less than 40 years old, less than 40 years old. Less than 40 years old mean 40 is not included, which mean you have to select these two. Get the summation of these two frequency, divide by total number of outcomes, you can get the value. I think it is clear for you. So, please try to do these examples again and again, then you can get the get a better idea about how we use these kind of problems, or how we use these, how we solve these kind of problems by using our probability theories. Okay. This is the same picture I showed you few slides before. Find the probability, the sum of the dice is 8. Okay, this is really interesting question, actually question type. Okay. The sum of the dice is 8. So, what does the sum of the dice mean? Consider this guy. What is the sum of these guys? This is 1, this is 1. So, sum 2, right. This guy sum 1 plus 2, 3. This guy sum 1 plus 3, 4. So on, right. This one sum equal to 1 plus 6, 7. Clear. Same thing here. If I catch this one, sum 6 plus 1 7, right, so on. You can write down the sums. So this sum of the dice is 8. So you have to check what are the 8. What gives me the sum? 8. What about this one? 4 plus 3 7, right, it's not 8. So 8, see, 4 4 8. Any others? If I have 6, yes, here, if I have 6, then I have 2 8, again 6 2, right, 5 3 8, 5 3 8, right. So this is some kind of diagonal case. So we have 1 2 3 4 5, we have 5 of them, we have 5 of them. So the probability is we have 5 of them divided by how many? Total number of outcomes. There are 36 outcomes. Do you remember that? 36. Okay. So 5 over 36. I'll skip a few of them and I'll do sum. Oh, okay, I'll do this one. Sum of the dice is 1. Okay, this is very tricky. Sum of the die is 1. So you have to find what are the pairs which we have, which we give sum is equal to 1. Do we have that kind of pair? No, we don't have. We do not have sum is 1. So we do not have. So probability is 0. Okay, it is not happening, right? So that's not going to happen. So likewise, you can follow this example and try to polish up your probability knowledge. Okay, I think up to this point you may clear. Now you may have a rough idea how to deal with this kind of probabilities. So hope you guys enjoy the video, and thank you for joining with this video series. I'll continue this lesson in future videos.